Hey boys and girls, today for our math lesson we're going to have Mrs. Walker help teach us again. I really like her videos. I like how she gives you lots of practice time and she explains things very well. So we're going to have her teach you more about perimeter today. Last week, was it last week? We did the activities where you had to do the area or number pieces. That's what we did. So you had to go to the number pieces app and I gave you an area and you had to find rectangles for that had that area. This week is going to be a little bit different. This week I'm going to give you the perimeter and you're going to have to figure out how to make rectangles, how many different rectangles you can make with a certain perimeter. And this is kind of tricky and she's going to kind of walk you through a couple different ways on how you could figure out your rectangles. So go ahead and watch her video. If she asks you to pause and do something, I want you to pause and do what she asks. I attached the problem set question number 1 that she does along with this video, so you can pause the video and work on the problem set. And when she says to get out the square tiles, you can do that in your Number Pieces app. I would definitely recommend pulling out the number of square tiles that she asks you to in the Number Pieces app to help me make these rectangles. If we were in class, I would just give you everything that you need and then we would just do it all on our desks and do it together. But I'm going to need you to do it independently by yourselves. Use the Number Pieces apps to help you and then follow her directions that she gives. This will be a long video. You can see down there at the bottom. It's about almost 18 minutes long. I was thinking originally that we would just cut this lesson up into 2 sections, but we're just going to do it all today and just get it all done and out of the way. So here we go.
Hey friends, it's Mrs. Walker. For our lesson today, we're going to continue to talk about area and perimeter. So our learning goal says I can construct rectangles with a given perimeter using square units and determine their areas. So friends, all that means, in this lesson, we're actually going to be given the perimeter and then we're going to have to find the area of the rectangles. Okay, so the materials that you'll need for this lesson are your dry erase board. You'll need those square tiles. Again, if you don't have those, it's okay. You can get by this lesson without them. But if you have them, fine. And you'll need your problem set because we're actually going to work through problem number 1 on your problem set. And good news, there's only 2 problems. So after this video, you'll be halfway done with your problem set. All right, so let's look at problem 1. Okay, so the directions for this first part say, use your square unit tiles to build as many rectangles as you can with a perimeter of 12 units. So how is this problem different from the work we've been doing in the past few lessons? Kind of got to think about that for a minute, right? So how is it different than what we've been doing? Well, maybe you're not sure, right? So before, we knew the area of the rectangle and had to find the length and width. Now we need to use the perimeter to find the length and width. So we're kind of like going backwards or doing like the opposite of what we did before. So now we're working with the perimeter to find the length and width. So we know the total, but we don't know individual side lengths. So when we knew the area, we used pairs of factors to help us find the length and the width. What strategy might we use to help us when we know the perimeter? What do you think? Right, well, we could like build or draw the rectangles with different lengths and widths to see if the perimeter is 12 units. But that might take too long. So let's see if we can figure out maybe a strategy we can use with another problem. So let's check out this one. So here is my rectangle. Okay, all of my side lengths are known in this one. Now, the equation that I have says P, which stands for perimeter, equals 2 times 3 centimeters plus 8 centimeters. So how does this equation represent the perimeter of this rectangle? So I want you to pause and I want you to think about how does that equation represent the perimeter of our rectangle. So pause and then think about that for a minute and then click play when you're ready to go over it together. All right, friends, pause if you need more time. Okay, so friends, let's actually look at this by solving the part in parentheses in our problem. So if we know that perimeter equals 2 times, well, we want to solve this part right here, which happens to represent these two side lengths of our rectangle. So friends, what's 3 centimeters plus 8 centimeters? Yeah, it's 11 centimeters. So when we multiply a number by 2, what are we doing to that number? Like, what's really happening to that number? Yeah, we double it, right? So we're really just doubling a number when you multiply it by 2. So believe it or not, friends, this top equation actually does represent our rectangle, the perimeter of it. Because notice, if we were to add 3 plus 8, we get 11, right? But if we multiply that by 2, we would be getting the other two sides because they're the same in a rectangle. So this equation shows the perimeter as double the sum of the width and the length. So let's check it by multiplying 2 times 11 centimeters. So friends, what's 2 times 11? Yeah, it's 22 centimeters. So if we add the side lengths, we also get 22 centimeters. So let's kind of check it. So friends, what's 8 plus 8? That's 16, right? And then what's 3 plus 3? 6. So what's 16 plus 6? 22. Okay, so that's just a different strategy you can use to solve it. But this is really, using that doubling is really going to help us today with our problem set. All right, so can the perimeter of all rectangles be written as double the sum of the width and the length? I know that sounds kind of confusing, right? At least the first time I read it, it was a little confusing. But all that that's saying is if we take the sum of two sides, right, the two sides next to each other, like the 3 and the 8, and then we double it, is that going to be the same for all rectangles? Absolutely it's going to be, because all rectangles have opposite sides that are equal. So really, 3 and 3, you're doubling it. 8 and 8, you're doubling it. So if you just add two of those sides together and double it, you're going to get your perimeter. Pretty cool. All right, so notice here, friends, I just want to call your attention. So if we have 3 plus 8 and we double it, we're adding this other side here in blue too. Okay, so just kind of a visual way to look at it. When you have the yellow, you double it, and then you also have the blue. The yellow and the blue are how you double those sides to get your perimeter. All right, so again, here's our problem for problem 1. Okay. So let's see how knowing that strategy where you double the sum of the side lengths help with problem 1. Okay, so it asks us to use unit squares to build as many rectangles as we can with a perimeter of 12 units. So we know that the perimeter, 12 units, is double the sum of the width and the length. What's the opposite of doubling a number? So if we don't double it, what's the opposite of doubling something? Yeah, it's like dividing it by 2 or halving a number, like halving, right? If you take it and you cut it in half, okay? So let's look at that. So 12 divided by 2 equals 6. So if we're using this equation to help us find the perimeter of the rectangle, what does the 6 in this equation represent? What do you think, friends? Yeah, we divided the perimeter by 2, so 6 is the sum of the width and the length. Okay, because we said we doubled the sum of the width and the length, and that's how we get back to 12. But when you cut it in half, that gives us the sum of the width and the length. Pretty cool. Okay, so again, we have 12 divided by 2 equals 6. So now that we know the sum of the width and the length, we can find pairs of numbers that add up to 6. So let's start at 1 and write the number sentences that have a sum of 6. So think about it. 1 plus 5 equals 6. Then we would go to 2. So 2 plus what equals 6? Yeah, have 4. 2 plus 4 equals 6. Then we would go to the next number, 3. 3 plus what equals 6? 3 plus 3 equals 6. Now, then I would go to 4, and then it would be 4 plus 2. But I don't have to write that because I already have 2 plus 4. And then I would go to 5, and 5 plus 1. I don't have to write that because we already have 1 plus 5. And we definitely wouldn't go to 6 because that would be 6 plus 0. And you can't have a side length of 0. That wouldn't give us a rectangle. Okay, so I'm going to move this up here. So those are the numbers that we came up with. What do these combinations represent? They're the possible widths and lengths for a rectangle with a perimeter of 12 units. Wait. How do we know which is the width and which is the length? What can we do? So we're going to sketch a rectangle one way and then trade the numbers that go with the width and length and sketch again. And notice what happens. So that's kind of tricky. All I want you to do, friends, is I want you to draw a rectangle that's 1 by 5 and then draw a rectangle that's 5 by 1. Okay? So pause the video. Draw 2 different rectangles, 1 by 5, 5 by 1, because we're taking that from our problems up in their box, right? And seeing how would we determine which one is the length and the width. So pause the video, draw those 2 rectangles, and then click play when you're ready to go over it together. All right, friends, pause if you need more time. Okay, so here's the 2 rectangles that I drew. One is 1 by 5, and one is 5 by 1. Okay, so what do we notice about these 2? Yeah, it's the same rectangle, right? It's just flipped. So it doesn't really matter, like for now, which one it is. But I would think about it when you draw it, just make sure that the smaller number is the smaller side length. Okay, whether you draw it side to side or up and down, it doesn't matter. Okay? Okay, so now you're ready to complete problem 1. But, you might be feeling like, I'm not super sure. So, you know what? We're going to go through number 1 together. You're going to work in each part, and then I'm going to go over it with you. Okay? So, don't worry if you don't feel 100% confident in this. We're going to keep talking about it. And I think when we have some more examples, it'll definitely make more sense. So, for part A, it's draw the rectangles. So, here's the rectangles that you're going to draw. Okay? You're drawing a 1 by 5, a 2 by 4, and a 3 by 3. Okay, because it wants you to draw the different possible combinations that have a perimeter of 12 units. Now remember, we figured out those combinations because we divided the perimeter in half and then found the the combinations of numbers that add up to make that number that was in half. So 12 divided by 2 is 6. So we found all of the combinations that we could add together to make 6 for the side lengths. Okay, so pause the video, draw those 3 rectangles and label the side lengths, and then click play when you're ready to go over it together. All right, friends, pause if you need more time. Okay, so here's our rectangles, right? I'm going to label them A, B, and C because that'll help us with the other parts, okay? So if you haven't done that, do a quick pause real quick and label your 1 by 5 rectangle A, your 2 by 4 B, and your 3 by 3 C. Okay. All right, friends. So those are your rectangles, right? We just took it right from those combinations that we came up with. We have a 1 plus 5, a 2 plus 4, and a 3 plus 3. Now, I want you guys to notice that you can check to make sure that these all have a perimeter of 12 by adding the side lengths. So if we look at rectangle A, if I added 5 plus 5, that's 10, plus the 2 1s is 12. Okay? Let's look at B. 4 plus 4 is 8, plus my 2 side lengths of 2 is 4, so 8 plus 4 is 12. And then if I add all of my side lengths on C, we would also come up with 12. So that's why these 3 rectangles represent a perimeter of 12 units. All right, let's look at part B. It says, explain your strategy for finding rectangles with a perimeter of 12 units. Now remember, friends, that's where we use the strategy of dividing by 2 and then finding those combinations like we have in the box. So now you're going to use written words to describe how you figured that out. And this part is super important because you're going to use this strategy when you do problem 2 also. So this problem is where you're understanding what we're doing in this lesson. Okay? So pause the video, explain how we figured out what those rectangles would be, the side lengths would be, when only knowing the perimeter. Okay? So pause the video, write your thoughts out, and then click play when you're ready to go over it together. All right, friends, pause if you need more time. So what did we do to find the rectangles with a perimeter of 12 units? Well, this is what I came up with. First, I divided the perimeter by 2 to get 6, right? So if we think back to it, we did 12 divided by 2 equals 6. Then I found pairs that added to 6 to find the possible side lengths. Okay, so that's what I jotted down for part B. All right. And friends, hang on, let me go back to this. If you didn't get this, that's okay, jot it down now. Pause the video, jot it down, because you can refer back to this as your notes to help you solve problem 2. Okay? All right, let's look at part C. Part C says find the areas of all the rectangles in part A above. Well, I can't look above, so I just made some little ones right here so I could refer back to it. So you are finding the area of rectangle A, rectangle B, and rectangle C. Okay? Remember, friends, how do we find the area? Yes, length times width. Okay, so pause the video, find the area of rectangle A, B, and C, and label them as A, B, and C so we know, and then click play when you're ready to go over it together. All right, friends, pause if you need more time. All right, so let's start with rectangle A. So we need to find the area. Here's rectangle A. We would do 1 unit times 5 units to come up with 5 square units. Now remember, if you don't have square in there, you need to be adding that part in because that's telling us that it's the area, right? It would be square units because it didn't tell us the measurement, whether centimeters or inches, so we would say square units. We would also say maybe if the measurement was centimeters, we would say square centimeters. Okay, so remember, square is that giveaway that they're looking for the area. All right, let's look at rectangle B. We would have the side lengths are 2 by 4, so we would have 2 units times 4 units equals 8 square units. Okay, let's look at C. 3 units times 3 units, those are the side lengths, would give us 9 square units. Okay, so those are the areas of rectangle A, B, and C. All right, so part D, the perimeters of all of the rectangles are the same. What do you notice about their areas? So we know that they all have a perimeter of 12 units. I want you to pause and think about what do you notice about the areas that go along with those rectangles. So pause, think about that, write your answer down for part D, and then click play when you're ready to go over it together. All right, friends, here we go. So what do you notice? They're all different, right? They all have the same perimeter, but rectangle A's area is 5 square units, B is 8 square units, and C is 9 square units. Okay, so in this lesson, we can see that rectangles can have the same perimeter, but they don't always have to have the same area. Okay, so good job with that, friends. All right, guys, so now that we've done this one, you guys are ready to work on number 2.
Alright, boys and girls, and that's where the video ends for today. I'm not going to make you do number 2 on the problem set because I know that you already worked really hard on number 1. And that was a big concept to understand. So if there's something that you don't get, just rewind the video and watch that part again. Or comment below and we can set up a Google Meet so I can help you. And that is your math lesson for today. Have fun and good luck.